Okay, guys, this is another video about the similarity. So we have a triangle, a right triangle right here. We have the larger one right here. So before we get started, we need to remember we have three similarity like criteria for the triangles: angle, angle, side, angle, side, and side, side, side. So we can use one of these three to determine if the given triangles are similar. Okay. So in this case, we cannot use this guy because there is only one side of this triangle is given. So we cannot use this guy because we need to know all three sides. So that's not possible. And then I cannot use this side angle side either because in this triangle, I have only one side. I need to know two sides and the angle in between those two sides, okay? Which is our only shot that I have is the angle. It looks like we have 90 degrees for sure, okay, in this triangle. And then we have the 90 degrees in the larger triangle as well. But if you look at the angle A is also common. And then as I stated before, if that makes it easier for you to see the corresponding parts, so you can actually draw the triangle separately, which is usually helpful. Okay, so you can make those two given figures separately, right? And I'm gonna do right here. Okay, so this is 90 degrees, which is D, and this is E, and this is A, that's B, C, and A. So we know this guy was the same as angle A, which is the same angles. And then this was 90 degrees, this is 90 degrees. So we have already two angles are equal in this triangle and this triangle. So they are similar. So this is 3, and this is X, and that's 11. And then AD is X plus 9. Okay, so that's X plus 9. So these two triangles are similar. I can really write the similarity as well. So the triangle ABC is similar to, so I start with A, I should go with A. And then B is 90, so D is 90. And that should be D. And then the reason is angle. Okay, so now we can like say, as a general like reminder, whenever you can show two triangles are similar, or any figures are similar, that means their corresponding angles are congruent and their corresponding sides are proportional. So then I can just go and write the sides. So in this case, if I start with this X, that's the side that is opposite the third angle. In my other triangle, the third angle is E, that's opposite to X plus 9. So that should be corresponding to that guy. And this ratio should be same as in the smaller triangle, this angle A is opposite to 3. The angle A in the larger triangle opposite to 11. So that needs to be same. Again, if you want to continue with one more step saying that AC divided by AE is also the same ratio, that's okay, but it doesn't really what we need at this point because we don't really care about those two sides. We just need X, okay? So at this point, I can do cross multiplication. So 11 times X, just 11X. And then 3 times of these guys, X plus 9. So I can expand these, right? So 3X plus 27 is 11X, and subtract 3X from both sides, which is 8X equals 27, and X should be 27 over 8. And that is my answer because that's what they are asking for, okay? So let's take a look at actually 27, 8, and that was correct. So let's move on to the next problem. So it's the same thing, but if you remember the previous problem, we have actually really nice going on, like which is sometimes easier to deal with to make our life a bit less less work or less miserable. So this ratio is X over X plus 9. What does that look like? If you look at the previous figure, the X was right here, X plus 9 was the longer one. So this was our X and this was X plus 9 in our previous problem, which means this divided by this, X was right here, 11 right here. I mean, 3 was right here, 11 right here. So this guy divided by that is equal to AB divided by AD, which is something you can easily do that in these kind of questions. So you can say, okay, this guy divided by this is equal to this divided by that. So you can say 4 over 7 is equal to 2 over x. And then if you do cross multiply, so 4x will be 14, divide by 4, so you will get 7/2. You can go with this. There is nothing wrong with that. But for now, if you don't really see why this is the case, I'll actually make it a bit longer as usual. Okay, so we can actually see why they are actually the case. Okay, but let me make this piece gone from this picture. Okay, so I'll do the same thing. I'm gonna make the triangle again separate. Okay, so then I do have now something like this, and then I will have the smaller one. Okay, so I hope that will work out. So this is 90, this is 90, so that's A, that's B, C, that's A, D, E. Okay, so this is 2, this is 4, and AD was 4 plus 3, 7, that's X. So, you know, the angle A right here is the same as angle A, and then D and B are 90 degrees, so they are similar by angle, which is, I'm not gonna write it for now. Actually, let's write it. So the angle ABC, I mean triangle ABC, is similar to, so ABC, ADE, okay? So ADE by angle. Okay, so then now the ratio is like, if I start with this 4, then the corresponding side is gonna be 7, so 4 over 7 is equal to angle A is opposite to 2, the angle is opposite to x. So that was the equation that we have, right? So to cross multiply, so 4x is 7 times 2, divide by 4, so you will get 7 over 2 for my x, okay? Again, the same reasoning, like whenever you see this kind of figure, so you don't really need to go through those process. You can just say, okay, ratio of this AB to AD is equal to this guy divided by that. That will be way faster and much better than maybe this one. But if you are not sure which one was divided by which and stuff like that, so it's good to draw those separately and do that way as well. Okay, so that is my answer for this question as well. I hope that makes sense. I'll see you next time.